All right, moving on to section 2.5, zeros of polynomial functions. So this is the last section before your quiz. So after this 2.5, we'll be ready to do a quiz. So let's look at, first of all, we're finding zeros of polynomial functions. And an important theorem to know is the fundamental theorem of algebra. Fundamental theorem of algebra. So here is your formal definition given there. But basically what you need to know is that for the fundamental theorem of algebra, what this is, it's testing for how many zeros there are in the function. So basically, the degree of the polynomial tells us how many zeros there are. The degree of the polynomial tells us how many zeros there are. So this is the total number of zeros, the total number of zeros, and this includes both real and complex. So the total number of both real and complex. All right, and then the degree here, when we're saying the degree of the polynomial, the degree is the highest exponent. Okay. So that's the basis of it. So let's look at your first learning target. I can use the fundamental theorem of algebra to determine the number of zeros of the polynomial function. So the first thing you want to do for your success criteria here, step one, determine the degree of the polynomial. So let's look at example 1 here. The degree of the polynomial is my highest exponent, so this has a degree of 2. Okay, and then that degree is the total number of real and complex zeros. So that means I'm going to have 2 total zeros in this polynomial. And that's it. That's the fundamental theorem of algebra. So pause the video and try 2 and 3 on your own. All right, let's check it. For number 2, I have a degree of 3, so that means there are 3 zeros. And for number 3, I have a degree of 4, so that means there are 4 zeros. Okay, so the fundamental theorem of algebra tells us how many zeros we're going to have. Now let's move on to what's called the rational zero test. Now the rational zero test tells us all the possible rational zeros. So out of those total amount of zeros, the rational zero test is going to tell us how many possibilities we have for the rational ones. So let's highlight this. This is important. So the zeros can either be rational or irrational. And then out of those rational, we can use the zero rational test to give all the possible rational zeros. Okay, so what the rational zero test is, to find all the possible rational zeros, we're going to do P divided by Q. And what that means is P are all the factors of the constant term. So this term at the end here, so the last term is my P, And then the coefficient of my first term is Q. Coefficient of first term. All right, so let's look at an example here. So number 4 here, our next learning target, I can use the rational zero test to provide a list of all the possible rational zeros. So these aren't going to be the actual zeros, these are just all the possibilities. So what you're gonna do, success criteria, step number 1, you want to make sure your polynomial or your function is written in descending order. So I have to the third, to the second, to the first, and then the constant. So that's in order. Now I'm going to label my P and Q. That's why it's important to make sure that they're in order, because your P and your Q need to be in the first position and the last position there. All right, so that's my P. The last term is my P, and then my Q is the coefficient of my first term. So that's my Q. So my Q is 1, and my P is 6. All right, so that's step 2. P is last, Q is first. We got those labeled. All right, step 5, we're going to list all the factors of P. So here's my P is 6. What are all the factors of P? A good way to do it, if you don't know it right off the bat, you can list what multiplies to get 6. So I have 1 times 6 and 2 times 3. So all the factors would be 1, 2, 3, and 6. And we're going to write that as plus or minus there. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So those are all my factors of P, of 6. Now I'm going to do the same thing for Q. All the factors of 1, well, that's just 1. Plus or minus 1. Okay, so I found all the possible factors of P, and then I'm dividing it by all the possible factors of Q. All right, so now we're on our last step, which is to simplify and reduce if possible. So I need to do 1 plus or minus 1 divided by plus or minus 1. Well, that would be plus or minus 1. And then plus or minus 2 divided by plus or minus 1, plus or minus 2. And then 3 divided by 1 is 3, 6 divided by 1 is 6. So these are all the possible zeros. Positive 1, negative 1, positive 2, negative 2, positive 3, negative 3, positive 6, negative 6. Those are all the possible zeros. All right, pause the video and try number 5. All right, so let's go over number 5, see how you did. I'm going to check to see that they're in descending order, so 4, 2, 1, constant. We're doing good there. Now I'm going to label my P and Q. So my Q is 3 and my P is 8. And then I'm going to start listing my factors. So I have P divided by Q. So factors of P, I have 1 times 8, 2 times 4, and that's it. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Now the factors of 3, that's just 1 times 3, so plus or minus 1, and plus or minus 3. And now I need to go ahead and simplify. So 1 divided by 1 is 1, 2 divided by 1 is 2, and then 4, and then 8. Now I have to take the 3, so I have 1 divided by 3 is 1/3, and then 2/3, and then 4 over 3, and 8 over 3. Those are all plus or minus. And then those are all the possibilities, and none of those can be reduced. So that would be your answer there. All right, that's the rational zero test. Let's turn the page and use this rational zero test to go ahead, and now we're actually going to find the zeros. So the fundamental theorem of algebra, just to recap, the fundamental theorem of algebra tells us the total number of zeros, and then we can use the rational zero test to find all the possible rational zeros, and then we can use those possibilities finally to determine all the real zeros. All right, so number 6, example number 6, we're given a function, a polynomial here. So first we're going to use our rational zero test to find all the possibilities. Let's do that first. So we're going to label, we'll make sure they're in descending order, and then we're going to label our P and our Q. And we'll find the factors of P and list them. And then the factors of Q and list them. And then simplify. So everything divided by 1 is just itself. And then I'm going to divide by 2. So 1/2. 2 over 2 is 1, and we already have that, so I don't need to write that. And then I have 3 over 2. And then 6 over 2 is 3. I already have that, so I don't need to write that. So those are all my possible. All right, so now that I have my possible, now I'm going to use those to help me find all the zeros. What are the actual zeros? I know from the fundamental theorem of algebra that there's going to be 3 of them, so I need to find 3 zeros of this polynomial. So how you do that is you start with your possibilities. So you can pick any of these. It doesn't matter which one. Usually it's a generally good idea to start with the 1, the plus or minus 1. But you can test all of these until you find one that works. And you know that it'll work is after you do synthetic division, you'll have a 0 remainder. So in order for this to be a 0 or a factor, it has to have a 0 remainder. So let's try this out. Let's start with positive 1. So I'm going to use synthetic division using positive 1 here. So I use 2, negative 3, negative 11, and 6. And then I'm going to use synthetic division. So I start by bringing down my 2, and then my process is multiply, add, multiply, add, multiply, add. So multiply 1 times 2, and then add negative 3 plus 2, negative 1. Multiply 1 times negative 1, add, and you get negative 12. Multiply and add. So my remainder here is negative 6. That is not a 0 remainder, so that means no, 1 is not a 0. So I need to keep going. I need to keep going until I find one that works. Let's try positive 2. Let's see what happens with that one. Two times 2 is 4, add, get 1. 2 times 1 is 2, add, get negative 9. Multiply, add. That's a no. Gotta keep going. Gotta keep going until you find one that works. You know what works when you have a 0 remainder. Let's try 3. Okay, multiply and add, multiply and add, multiply, yes. Look at that, we have a 0 remainder. That means that 3, positive 3 is a 0. Okay, so that's our first 0. Once we find a 0, so x equals 3 is a 0. Now to find the other zeros, we can take this quotient here, all right, and factor it. So this would be 2x squared plus 3x minus 2. So let's just recap here. So we started by listing all the possible zeros, and then we're using our synthetic division to test them all until we find a 0 remainder. So you have to keep testing until you come to one that has a 0 remainder. Once you find one, now you can take the quotient here. So this is my quotient, and I'm going to factor it. All right, so we're going to find the remaining zeros by factoring the quotient, and then finally solving for x. So I'm going to go ahead and factor 2x squared plus 3x minus 2. This is a trinomial where a is greater than 1, so that means we have to do the process of factoring by grouping. So we're going to do 2 times negative 2, which is negative 4. And then I'm looking for the factors of negative 4 that add to positive 3. So that would be negative 1 times 3. So I'm going to replace 3x with the negative 1x and 3x. Not 3x, 4x. Oh my goodness, Mrs. Oskey. Okay, because negative 1 times 4 is negative 4, but when you add them, negative 1 plus 4 is 3, and that's what we're trying to do there. Okay, so replace 3x with negative 1x and 4x. Here we go. All right, now we are ready to group them. And then we're going to find the GCF of each group. GCF here would be x. GCF of the second group would be 2. All right, common is 2x minus 1. I'm going to come on over here to have more room. And then left over is x plus 2. Now I'm going to solve for x. So I have 2x minus 1 is 0, x plus 2 is 0. So x is 1/2 here, and x is negative 2 here. And then don't forget, we also have the 0 of 3. So there's our 3 zeros that we were looking for. 1, 2, 3. So final answer, the zeros are x equals 1/2, negative 2, and 3. So we just found all the zeros. All right, go ahead, pause the video, try number 7. All right, let's take a look at number 7, see how you did. So step 1 of our success criteria is start with all the possible zeros. So what's our P and our Q? Here's our Q, here's our P. We're doing P divided by Q. So that would be 1 and 3 for P and just 1 for Q. So that gives us the possibilities of plus or minus 1 or plus or minus 3. And then we'll go through and we'll test and we'll test and we'll test. And then we'll finally come to negative 3. Let's check that out. And we'll see that that gives us a 0 remainder. So x equals negative 3 is one of our zeros. Now we can take what's left over, all right, and factor it. But you'll try and you'll see, wait a minute. X and X, what are the factors of -1 that add to 4? Well, there's none. So this is actually not factorable. So what happens when you come to a quadratic that is not factorable? How can you solve for X? Well, you can, dun dun dun, use the quadratic formula. All right, so we're gonna have to use a quadratic formula here. So this would be my A, B, and C. So A is 1, B is 4, and C is -1. Then we're gonna plug that into our quadratic formula. I'm gonna write it over here just for reference, just in case you forgot. There it is. All right, so X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And then we'll go ahead and simplify that out. Keep going. You can take that square root of 20, make my factor tree. So that simplifies to 2 square root 5. But there's still one more thing to do. You can still reduce it by 2. So finally you find that this is -2 plus or minus the square root of 5. And those would be our remaining 2 zeros because one's positive, one's negative there. So the total amount of zeros is X equals -3, and then -2 plus or minus square root of 5. Final answer. All right, try number 8 on your own. Go ahead, pause the video there. All right, let's check it. So make sure they're in order. 3, 2, 1, constant. Find your P and your Q and list the factors. Simplify those out. One half. All right, those are your possibilities. Then we're going to start our testing process, and we'll finally come to -2. And that gives us our 0 remainder. So I know that one factor is -2, and I'm going to take my 2x squared plus 2x plus 1, and I'm going to factor it. Oh. That's one of those where you do 2 times 1 is 2. So what are the factors of 2 that add up to 2? There aren't any. So this is not factorable. What happens when it's not factorable? Well, you have to use the quadratic formula. So we'll do that. Plug that into the quadratic formula. And start simplifying. Uh-oh. What happens when you get a negative square root? Negative square root, take it and you make it imaginary. So we're going to replace the negative square, or the square root of -4 with the square root of 4i. And what is the square root of 4? Square root of 4 is 2. So 2i. And then this, of course, can be reduced by 2. Final answer, negative 1/2, then plus or minus 1/2 I. Okay. Final answer, zeros are x equals negative 2, and then negative 1/2 plus or minus 1/2 I. Dun, dun, dun. There's your answer. All right, that concludes this lesson. You are now ready to do your OTI assignment in your book.